We have another example where our g of x here is involving trigonometric function, specifically sine function. But notice that in this given g of x, we also have a constant here. Now, we cannot just simply turn it over on the other side because this constant, if turned over to the other side, will become plus 3. It doesn't have the variable y being the a dependent variable, which would mean this is really a non-homogeneous equation. That's why we are just leaving 3 on the other side. In short, our g of x is, aside from being a trigonometric function, we also have a constant here. So there is an additional process involved here because the right-hand side involves two terms. Now, looking into this, again, the general solution is still expresses y sub c plus y sub p. The y sub c, as mentioned, is the general solution for, or the complementary solution, if this entire g of x is equal to 0. Hence, the process involving homogeneous higher order equation will be used here. Now, for y sub p, okay, so please look into this table. Y sub p is the particular solution involving the correct coefficients for the intended g of x. Supposedly, our g of x here is, the first one is sine of 5x. So we are going to look into the fifth row. Therefore, our y sub p is equal to the form of our y sub p on our fifth row. We have a cosine of our angle 5x plus b sine of our 5x. I suppose that should be the value. Okay, so we are going to look into the coefficients of a and b later on to be paired with y sub c. But here's the catch. Again, here is what makes this different from the previous two examples. Take note that our g of x contains constant here. In short, look at the first row. We also have another form for our y sub b, which will be used here, and that is actually equal to our a, being the constant here. So how would we try to combine these two if we have two different forms of y sub b and there are two coefficients for a? Now here's the thing here. We are going to call this y sub b sub 1 because that's for our constant, and instead of a and b for our trigonometric function, let's call them b and c. And yes, if you're thinking this, the correct is yes, we are going to solve for the y sub p sub 1 separately together with y sub p sub 2 and compare it later on to our given coefficients here. So with that, we will have two forms later on of y sub p. Let's look into that later, and this video would be probably 12 to 15 minutes so to discuss this carefully. Okay, let's start with y sub c. Y sub c is using this, so you will have for our fd of y, our equation with differential operator d, this will become d squared minus 7 of y is equal to 0. Hence, our auxiliary equation is m squared minus 7 equal to 0. So we can solve for y sub c here by solving for the roots of this given equation. So you have your m squared is equal to 7. By extracting square roots of both sides, you will have here plus minus square root of 7. Hence, your first root can be positive square root of 7, and your second root is the negative of square root of 7. Even if we have square roots, they are still real numbers. Hence, for your y sub c, we are going to use the general solution if we have distinct and real roots. It follows this form: c sub 1 e to the power of m sub 1x plus c sub 2 e to the power of m sub 2x. Now, it matters on which root you're describing first, but since I have here positive square root of 7 first, so your y sub c is expressed as c sub 1, just arbitrary constant, e to the power of the square root of 7, sorry, that's 7, square root of 7x, plus c sub 2 e to the power of negative square root of 7x. This is just for your y sub c. Okay, so for this portion here. Now, let's look into y sub p. As mentioned, there are two forms of y sub p here because our g of x has two forms. Okay, we have the constant and we have the trigonometric function. If this is just a multiplication, so we just simply need to use this alone. But since that's addition, so we're going to separate them. How do we do this? We of course look the same process. So let's look into y sub p first, sub 1, which is a. So we're going to have it later on compared to this, right? So we can actually look into this form here. Its first form, or first order derivative, is 0. And since we have second order derivative here, okay, so that's still 0. This will be patterned into the first form. You will have here y, double prime minus 7y is equal to just 3. We do not include sine of 5x, just for 3, because this is just for the first form. Take note that this could be separated into two forms, the constant and the trigonometric. That's why we don't include here the sine of 5x, because it will be paired with the other y sub p later. So by combining that and by using the y sub p's, so this is second order, 0 minus 7 times your y sub p sub 1, which is a, is equal to 3. Negative 7a is 3. So a is 3, that's negative 3 sevenths. Okay? In short, your y sub p sub 1, which is a component of y sub p, because this is both components of y sub p, is negative 3 sevenths. Okay? That's just for the term itself, I mean the constant itself. We need to look into the second component of our g of x, which calls for this, because that's for our trigonometric function. So let me copy that here. So y sub p sub 2, we're going to use b, okay? Cosine of your angle 5x plus c sine of your angle 5x. Take note, our original form is in this form, 3 plus sine of 5x. So for this, we will have this form here. And take note, we have until second order. So this first order derivative of this, so you will have here the constant b. The derivative of cosine 5x is negative sine 5x. And using the chain rule, the derivative of your angle is 5. Plus c, the derivative of sine 5x is cosine 5x times the derivative of your angle 5. Then that would be equivalent to this. So negative 5b sine of 5x plus 5c cosine of 5x. Okay, we may not need this later because we don't have the first order here, but we need this to come up with our second order. So let me remove some of my notations here, okay? So for our second order, for our p sub 2, so negative 5b as constant, the derivative of sine is cosine 5x times again the derivative of the angle 5 according to chain rule, plus 5c, the derivative of cosine 5x is negative sine 5x times again the angle, which is 5. So the second order of p sub 2 is minus 25b cosine of 5x minus 25c sine of 5x. So with this now, we're going to look into this form. And since we already used the constant 3 earlier just for this, take note of that, we will not be rewriting that here. In short, we will have this form, y double prime minus 7y, and we're going to use p sub 2's now, is equal to just sine of 5x. Hopefully my spaces here are enough. So let me copy here. I have here for y sub p sub 2, and this is for our second. So that's negative 25b cosine of 5x minus 25c sine of 5x. That's just for this term, minus 7 times y sub p sub 2, which is b, this one here, cosine of 5x plus c sine of 5x. These are all equal to sine, let me write here, rewrite this again. This is b cosine of 5x plus c sine of 5x. These are all equal to sine of 5x, this one here. Okay, so let's try to combine all of this and solve for the coefficients b and c to come up with our final form of y sub b sub 2. So you have minus 25b cosine of 5x minus 25c sine of 5x. Here, minus 7b cosine of 5x, and then minus 7c sine of 5x is equal to sine of 5x. So combining the cosine to the correct cosine, so minus 25 minus 7, so you have negative 32b cosine of 5x. You also have minus 32c sine of 5x is equal to sine of 5x. Okay, at this point, equate those with sine. And since we don't have cosine on this side, automatically that's equal to 0. So minus 32b cosine of 5x is equal to 0. This is only true if b is also 0. Okay? Now for your c, minus 32 sine of 5x is equal to sine of 5x dividing both sides. We have c here. Minus 32 sine of 5x to cancel this, leaving c. On the other side, minus 32 sine of 5x canceling that. So you have negative 1 over 32 for your c. Okay? That's for your c. Now, with this now, looking back to our y sub b sub 2, so it's b cosine 5x. So our y sub b sub 2 is b cosine of 5x plus c sine of 5x. Right? So you will have here, of course, b is 0. Y sub b sub 2 is just negative 1 over 32. That's for your c. Sine of 5x. Okay. Let's leave this remaining space here for our y. But take note, my y sub p was broken into two parts earlier using the constant. So you have here negative 3 over 7 plus, for your trigonometric function, let's not use plus because that's negative 1 over 32. So you have negative 1 over 32 sine of 5x. This is the combination of the two y sub p's. Again, the first y sub p, the first component, this happened because we have two terms for your constant. And for your trigonometric function is this. So combining that, you will have this y sub p, which will be combined to our y sub c here. Okay? So rewriting that, so our y sub c is c sub 1 e to the power of square root of 7x plus c sub 2 e to the power of negative square root of 7x. This was our y sub c earlier. Plus this. Or minus 3/7 minus 1 over 32 sine of 5x. So you can see this is very long, and the computation is a little bit complicated. This happened because our g of x is a combination of two different forms of functions. We have the constant and trigonometric function. So looking into that, we need to examine carefully our g of x, and of course with the use of the table presented earlier to come up with the final form. Thank you very much for watching.